Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the truth table, characteristic table and excitation table for the D flip-flop. So many students, in the previous lecture, we had just introduced what is a D flip-flop and what is the circuit diagram of D flip-flop as well as a truth table of D flip-flop. If we are dealing with a clock signal of 0, then the D flip-flop will preserve the previous data value, that is we are dealing with a memory condition, and if the clock signal is 1, then the data value will be stored, that is if D is equal to 0, then the output will be 0, and if clock equal to 1 and D is equal to 1, then the output will be 1. So this is the truth table of this particular data flip-flop. And the clock signal 0 means the Qn plus 1, that is the present state, is the Qn, that is a previous state. So this condition is known as a memory condition. And if clock equal to 1, D equal to 0 deals with Qn plus 1 equal to 0, and clock equal to 1, D equal to 1 deals with Qn plus 1 equal to 1. So now with this truth table, we are going to discuss about the characteristic table of the particular D flip-flop. The characteristic table deals with generating the Qn plus 1, that is the present state based upon the previous state as well as the input values. So here the previous state is Qn and the input value is D. So the different combinations of Qn and D are 0 0 0 1 1 0 and 1 1. And now we are going to discuss how the Qn plus 1, that is the present state, is being generated. So if we are analyzing the data value D is equal to 0 in the truth table, then the output, that is Qn plus 1, is equal to 0. Thus Qn equal to 0, D is equal to 0 deals with Qn plus 1 equal to 0. So now we are moving to the second case, that is D value is 1. From the truth table, if D is equal to 1, then output will be 1, that is Qn plus 1 is equal to 1. And if D is equal to 0, then the output will be 0, thus Qn plus 1 equal to 0. And if D is equal to 1, then the output will be 1, thus Qn plus 1 is equal to 1. That is, Qn plus 1 is always D itself. So this is an important case. Keep in mind that Qn plus 1 is equal to D in the case of a D flip-flop. So this is the characteristic table of this D flip-flop. So now we are generating the excitation table. So this excitation deals with the conversion of flip-flop as well as the different sequential circuit generations. So excitation table is very much important in the case of a digital electronic environment. So the two inputs for excitation table are Qn as well as Qn plus 1, and the output will be D. So since we are dealing with the two variable inputs, that is Qn and Qn plus 1, the different combinations are 0 0 0 1 1 0 and 1 1. And now let us see how the output D is generated in this excitation table. So this excitation table is created with the help of characteristic table. So if we are analyzing the Qn and Qn plus 1 is equal to 0 in the characteristic table, the 0 0 condition is the first row condition that is marked over here, and in this case the output D will be 0, and thus in the excitation table 0 0 input results in an output of 0. And if we are moving towards the second case, that is Qn is equal to 0 and Qn plus 1 is equal to 1, in the case of characteristic table the output, that is the D value, will be 1. Thus the output will be 1 in the case of excitation table. And if we are moving towards the third case, that is Qn value is equal to 1 and Qn plus 1 is equal to 0, here in this characteristic table the data value will be 0. Thus the excitation table's output D will be 0 over here. And if we are moving to the final case, that is Qn is equal to 1 and Qn plus 1 equal to 1, then the D value is 1. Thus the excitation table's output will be 1. So many students, this is how we are creating, or we are generating, the truth table, characteristic table and excitation table. So in this case the characteristic table is generated with the help of a truth table, as well as a excitation table is generated with the help of a characteristic table. And it is very much evident that in the characteristic table the output qn plus 1 is always depending upon the data input, that is qn plus 1 is d itself. Qn plus 1 is equal to d itself. So my dear students, so this is the truth table, characteristic table and excitation table of D flip-flop. D stands for data or delay. So my dear students, hope you had understood this topic. So dear students, kindly write down the assignment question. Our question is, write notes on characteristic and excitation table for the D flip-flop. So my dear students, in the upcoming lecture we will discuss the JK flip-flop. So it is another important type of flip-flop used in the digital environment, and let us see the JK flip-flop in the upcoming lecture. So dear students, see you soon. Until then, goodbye, thank you and all the best.